Hello friends, in this sessions we are going to learn about the CPU. You know that the CPU is the most important component in the motherboards. So CPU is like a brain of the entire motherboard systems. So in this sessions we'll learn how the CPU works, what are the things required to run the CPU, how to identify the CPU number, how to identify the generation, how to identify whether it is i3, i5, i7, and we are going to learn what are the test point, how to diagnose the CPU. So everything is we are going to learn in this two sections of videos. So I hope you will enjoy this video. So first thing is this is a basic concept of we learn the basic concept how the CPU works. The CPU is called the central processing unit, is the brain of the entire computer, and there is a three important sections in the CPU. The first section is called the arithmetic and logic units. The arithmetic and logic units perform the calculations and decisions, is like a calculator, perform all the mathematical functions and then the logical functions. So whatever the instruction goes, it is a process in the arithmetic and logic units and send the result out. So that is the job of the arithmetic and logic units. The second important unit is called the control units. The control units is a coordinating processor steps, like its coordinate internal and the external devices. That is the job of the control units. And the third important points sections in the CPU is called the register. Register is something called the small amount of memories which is inside into the CPU. The most important file which required to the ALU, that will be kept into the register. So whenever ALU require all those file, he can easily access and the result will be fast. So that is called the register. Okay, so these are the core sections of the CPU: ALU, control unit, and the registers. This is the core sections of the entire CPU. Okay, now we'll go ahead. In this sessions we'll see how theoretically CPU works. So first, what are the things required to run the CPU? First, CPU require a different level of powers or the voltages. In modern day CPU, there are three level of voltages are required. That is VCCP, that is something around 1.05. Then VDDQ. VDDQ is a RAM voltage, that is somewhere around 1.5 if the DDR3 RAM and 1.2 if the DDR4 RAMs. And then CPU core voltage, and in modern CPUs require a graphics core voltage also. So these are the three or four level of voltages are required to run the CPU. After powers, then there is a one more important signal is required to the CPU, and that signal is called the power good signal. Power good signal is a confirmation signal saying to CPU that whatever the power you got, all are perfect, all are stable, and you be ready to function, and that called the power good signal. The power good signal is basically a 1 volt signal. Okay, and then there is a one more important signal is called the reset. It's called the host reset or called the CPU reset. This is a 1 volt signal. When the all powers got to the CPU, at that time the reset is become a 0, and then it within a few millisecond it come back to 1 volt, and within that millisecond is clear the entire section. So whatever the junk information inside in the CPU, that will be cleared by the reset signal. Reset signal is basically used to clean all the junk information within the CPU. Okay, so these are the three important signal to run the CPU, and then the final fourth important signal is called a clock. The clock is oscillating pulses given to the CPU, is given the frequency to run the program counter. The clock is depend on the CPU's speed. So moreover, the more clock the CPU perform, the faster. So that is the use of the clocks. Okay, in modern CPUs require a crystal, so crystal generate the clocks, and that clocks will be provided to the CPU to run. Okay, so these are the four important signal to require to CPU. Okay, now here you can see in the inside, so this is the core sections of the CPU, and in this section it's called the ALU, or it's called the arithmetic and logic unit, which perform mathematical and logical duties. Okay, so here is the input, this called the data line, this called the address line, and third line is called the control line, which coordinate between the internal and the external devices. From the data, from the when the program start counting, then the address bus will be generated, and that address bus will be fetched to the memory, and from the memory the data is processed, and this data is given to the CPU, and the data and this bus is called the data bus. All the data is entered into the CPU and stored into the cache RAM, and one after another this instruction is executed by this ALU, and all those instruction by check by this instruction decoder. You check all the instruction, decode their meanings, and given to the ALU, and accordingly ALU execute all those instructions and generate the final result, and that result will be stored in this register, and that output will be sent to the data bus again to the outside world. So this is a basic overview. I explain about the CPU, how the CPU works. So we'll go to the next slides. Now we'll see our new generations of CPU, what things are required. So here I given the example of this Core i3 third generation CPU, and this CPUs require a total of 4 level of voltages, that is a power. First is called the VCCA voltage, that is a 1.05 voltage. Then there is called the VDDQ, that is a 1.5 voltage. Then the graphics core voltage is supposed to be a 1 volt 10 ampere current. And then finally it's called the CPU core voltage, that is a 1 volt and 30 ampere current. So these are the 4 level of voltages are required to run the CPU. Okay. Once all these 4 voltages got to the CPU, then the controller circuitry generate this signal is called the CPU power good. The CPU power good is a 1 volt signal given to the CPU, saying to CPU that the whatever the you power got from this, all these 4 inputs are stable, so you are now ready to work. And then after the CPU got the reset 0 volt and come back to 1 volt, the CPU get reset or clear all the junk information, and the next is clock started generating the frequency. From this clock, program counter will start and executing the instruction. There are the total 3 buses in the modern day CPU. One is called the DMI bus for the data buses, another is called the FDI bus for the graphics informations, and the third is called to communicate with the RAM, DDR RAM. And for RAM, there is address and data bus, clock line, chip select line, read line, and write line. So this signal you can use to check the CPU whether it is working or not. In next few slides, we'll see all this testing informations about the CPU, whether if the CPU is dead, then which are the important signal we have to check, and if there is a no display, then which are the important signal we have to check. Okay, but this is the basic overview I given about the CPU. Next important thing is the newer CPUs don't return their proper their number or generation, but they give the code, and that code is called a SPEC code or the SPEC number. So this is a 5 digits code which is there on the CPU. You can see here in this yellow circle the number start from SR. Here you can see this SR2 EY. So this is a code, and for this CPU the code is here is mentioned SR04R. So these are the code for the CPU. From this code we can come to know the generations and this which type of CPU it is, whether it is first generation, second generation, or i3, i5, or i7, how much the cache memory, number of cores, number of threads, number of architecture, everything is we got from once we google this number, then we'll got all the information about the CPU. So friends, just remember this code number, so you have to google this code number, and from this code number you'll get the all informations and the all detail about the CPU. Okay, so next is there are number of generations of the CPU. So nowadays there are total 12 generations, and Intel give their own different name for the generation. So the first generation CPU is come in the market in 2010, and that code name is a Westmeyer processor. And then second generations come in 2011, it's called the Sandy Bridge. Third generations come in the 2012, that is called the Abbey Bridge. Then the Haswell, then the Broadwell, then the Skylake, then the Capfi Lake, then the Coffee Lake, then the Ice Lake, then the Comet Lake, and then the Tiger Lake, Rocket Lake, and the last is Elder Lake, that is on 12th generation. So each generations have CPU have the different improvement, that is called the TDP. Then increase the speed, increase the number of cores, increase the number of threads, increase number of cache memory. So this improvement is going on day after day, and that's become the generations. Okay, so we'll see what are this differences is. So here we'll see what is the differences, because we can see that every year there is a new generations coming. See, new generation CPUs are coming, and we'll see what are the changes are going on within the CPU of that generation. So first the difference is called the TDP, or the thermal design power, or nanotechnology. So what is that? First we learn. So TDP, or the nanotechnology, is a CPU's die is made from the MOSFET. Though in the CPU there are lakhs and lakhs of MOSFETs are incorporated. In first generations CPU, the die is 32 nanometers, and in 12 generations CPU is somewhere around 10 nanometers and coming to the 8 nanometers. So the MOSFET size is decreasing. So what will happen if the MOSFET size is decreased? The number one is a power consumptions. Number one is a what? The power consumption. So what will happen is improve the power. So this first generation's CPUs 32 nanometers require approximately 30 ampere current to run the CPU, but this latest CPUs require hardly 8 ampere current. So a lot of power is saved. Okay, so that is the main advantage. Number two is a so these CPUs get very hot. They require very strong heat sink, strong fan. Okay, but the newer CPUs require only few small heat sinks and a little fan to run, because this cooling is very good. So there's a first advantage of this called the TDP. It's called the thermal design power. Second thing is number of cores are increases. In previous CPUs there is a single core. Single core means there is a single arithmetic and logic unit, single control unit, and single buffer, or that small amount of memory is called the register. But nowadays there is a multiple cores are there, like 2 core, 4 core, 8 core, 16 core. The cores are increasing. So what will happen if the cores are increasing? The core is like a individual CPU. Suppose in a CPU there is a single core, and lot of instructions are going into the CPU to execute. To to run that all the instructions, they have to wait because there is a single core. But if you have there are multiple cores, then instruction will be executed very fast. So like suppose there is a queue for to get the tickets on the ticket counter, but if there is only a single window, then what will happen is we have to wait to get our numbers at that queue. But if the multiple windows are open, like two windows or four windows or eight windows or 16 windows are open, so then in that case we don't have to wait to get the tickets, so everything will be the fast. So similarly, if the multi-core systems is there, multi-core processor is there, then the instructions have to no wait. They are executed very fast. The performance of the CPUs will be very high level. So that is called the core. So here you can see this processor have a 4 cores. This core number 1, core number 2, core number 3, core number 4. So there is a 4 core. So when the data is coming from the data bus, that will be executed by all the 4. The data get divided. Some core execute some core codings. The another core will decode another instruction, another code, like that. So the data get divided. The result will be very fast. So like that. So that is called the core. The next thing is called the multiple threads. So the thread is some virtual core. So here you can see this core have a 4 threads. You can see here the 4 threads. So what do you mean by thread? Thread is a virtual core of the processor. Here is a 4 thread, means one core have 4 time working capability, is a 4 time faster. So that is called the threads. Okay. So next thing is CPU core voltage decreasing day by day. In previously, the CPU core powers require a 30 to 40 ampere current, but nowadays CPU require hardly 7 to 8 ampere current. So the core power is decreasing, so that the temperature of the CPU is very less. Okay, so that is the main advantage. The power consumption is high, the battery durability is very high. The next is integrated everything, integrated controller. In Core Studio processor, there is a two chipset. One is called the North Bridge and another is called the South Bridge, or it's called the MCH and the ICH. And plus that Core Studios require a clock chips also. But later on, the MCH, ICH and clock chips is integrated into the single chips, and only CPU and the PCH work together. But in 2009, the CPU and PCH also integrated into the single chip. It's called the SoC. That means the system on chips. That means the CPU have everything within the chips. So this is called the integrations of the CPU. Now what will happen if they integrated into the CPU, that the performance will be very high. So that is called the integrations. Then integrated the graphics. The graphics chips also integrated. Here you can see in this picture, the CPU have the graphics processor inside into the CPU and have a separate bus, is called the FDI bus. From this FDI bus he communicate with the PCH, and this graphic chips directly connected to the display, whether is EDP or HDMI, or they have the separate PCI Express slots also. Okay, so this is called the graphics also incorporated in the CPU. And then the cache memory is increasing. These are the cache memory. Cache memory is the internal memory into the CPU. Our one memory is outside, is called the DDR, but there is another memory is called the cache memory, which is inside into the processor. Now what is the use of this memory? Whenever the processors require some important file to be kept near, at that time CPU keep all those file into the in those cache memory, so he can execute all the process very fast. The next is the clock speed is increasing. So what is the clock speed? Clock speed is the timing to the CPU. In previous CPUs work on a 4.43 megahertz, but nowadays CPUs run for 5 megahertz and above. So these are the main changes in the generations. So we can see there is the generation 1, generation 2, generation 3, now generation 10, 11, 12. So these are the only make changes in the processor. Okay, some new things are coming, like now this new generations come, processor comes in the ME region. ME is a manageability engine region, and in that one CPU is inside the CPU. That means the CPU is there, the CPU is there, but one more CPU is there which is inside the processor. He's like manager and observer. He's a manage, is called the CSME, converged security and manageability engine. Converged security means he check all the whatever the instruction, he check all the security wise and manage all the entire device. So this is called the CSME. So one more CPU is incorporated into the CPU. So my dear friends, so these are the basic these are the changes made into the CPU in the generation to generation wise. So what is the difference between i3, i5 and i7 processor? So here is a first generation comparison chart of the CPU. The Core i3 processor there are two cores. i5 processor have four cores and i7 processor also have four cores. But the threads, the i3 processor have two threads, i5 is a four threads and i7 is a total 8 threads. So here the i7 is overtake. So i7 will be the faster because you have the 8 threads. Turbo i3 don't have a turbo. i5 have a 3.8 GHz turbo. i7 had a 4 GHz turbo. Cache memory also you can see i3 have a 3 MB cache memory, i5 have a 4 MB cache memory, and i7 have a 8 MB cache memory. So here the i7 is a faster than these two processor. Okay, so this is a basic differences in generation to generation wise. So different types of processor will be there in laptop and desktop motherboard. In previous laptop motherboard, like from before generation 3, you can find the processor will like this is called the PGA processor. It's called the pin grid array, and you will see there are pins on the CPU. Okay, in desktop motherboard you can see the processor like this is called the land grid array, and this is called the LGA processor. So the processor don't have the pins, so all the flats, and pin is where the pins on the motherboard. But on the fourth generation onward laptop, you can see the processor is planted on the motherboard, and the processor have the small tiny soldered ball. The processor is mounted on the ball onto the motherboard. So this is called the BGA processor. It's called the ball grid array. So these are the three types of processors you can find on the motherboard. But most of the in laptop motherboard you will find a BGA processor only, and in desktop motherboard you will find the LGA processor only. Now there are different socket of the desktop motherboards called the 775, the core studio, which is outdated, then 1156 for the first generation, 1155 for the second and third generation, 1150 for the fourth and fifth generation, then 1151 for 6 to 9 generation, and then 1200 for the 10th generation. So these are the CPU sockets. So every CPU's generation sockets are different. So you can't fix one processor into the another generation. That particular generation will fix only that particular processor only. In laptop motherboard also the same thing. Now the newer generation is called the system on chip. So what is a system on chip? The system on chips means the processor and its controller. It's called the PCH, which will be merged into the single chips, and that is called system on chips. Okay, so here you can see this CPU and the PCH is a combined into the CPU, and this is called the SoC. So friend, this is a first part of the CPU. So in this sections we learn about the basic concept of the CPU, how to identify CPU number, what are the things required to run the CPU, how CPU internally works, all these things we learn. In next video we will learn detail about test point and diagnosing of the CPU.